So in this video we're going to be taking a look at this Nest machine on HqkLdap.exe, but this is a little bit different to most of these machines that we've done because this one, as you can see, was actually made by me. So we're going to go through the box from an attacker's point of view, but obviously as we go through things I can kind of point out my thought process and what I was expecting people to do and how I was expecting people to figure things out for each step along the way. And we can also talk about some of the things that people did that I wasn't expecting. And speaking of which, I'll also talk about the rather disastrous launch that the machine had, because there was a very big unintended skip, basically, that got you straight to local system or root, whatever you want to call it. Basically, the first set of credentials that you found, which are very easy to find, as you'll see in a minute, the first set of credentials basically just gave you root. So yeah, that was not good. Obviously, I fixed that very quickly as soon as I discovered that and sent HqkLdap.exe an updated VM. But yeah, that was a problem at first. But yeah, we'll go through that as we go through the box. So first of all, we'll do an Nmap scan like we normally would, if I can type. And we'll do T4-V to make it verbose. T4 just makes it slightly faster. And we'll do the first 6,000 ports as I normally do. Like I say, I'm going to kind of just attack this as I would any other box, but I'll kind of point things out on the way that I was thinking about as I was making it and what I planned for people to do. So we see straight away that there's only these two ports open. Port 445, which is SMB, and port 4386, which is some random port as far as we know at this point. And you can see Nmap says it's unknown, it's not a well-known port. Now, spoiler alert, this port is actually just running a custom service that I wrote, which we'll get into in a minute. But for now, we can't actually do anything with that. If we just try and telnet into there, so it was 10.10.10.178. I don't know why I opened up command prompt to use telnet. I could have just done it in there, but whatever. It's just a habit. So 178.4386. If we telnet in, we get this weird thing. We can type help. There's a few commands you can run in here, but we can't actually do anything yet. Like if we try and run any of these queries, and don't worry, I'll kind of explain this whole service when we get to that point. But all you need to know for now is we can't actually get anywhere really at the moment. We can, if we do setdr ... we can go up a level and actually start to list files. So we could use that to look around the C drive, do setdr C, and then list again. But we can't actually read any files at the moment, so it's not really a lot of use. Like just being able to list files doesn't help us that much at this point. So people could potentially get a little bit lost here when they're attacking it and just kind of look around here thinking there's something they can do, but hopefully it becomes apparent pretty quickly that all you can do is list files, you can't read them. So at that point, I was hoping that they would then go and look at SMB, although they might have just started with SMB, which a lot of people did. A lot of people didn't really spend any time on that from reading the write-ups, they just went straight to SMB. So let's do that. Let's go 10.10.178 and just see what we get. So we've got two shares and anonymous access must be enabled because we can get straight in, but we can't actually access any of these folders. So let's go back and try the data share. Can't get into there. Can't get into there. Can't get into there. But we can get into shared. So let's look at templates. This just happens to be the first one that I went into, but there's a couple of other just kind of dummy files that don't really tell you anything. But eventually, from looking around, I mean, there's not much to look through. As you saw, there's only a few folders. Oops, wrong one. Yeah, so there's not a lot going on. So people found this very quickly and easily. And long story short, there's some credentials in it that are just for like a temporary user account. I tried to make it kind of realistic, you know, it's just a temp user account for people that haven't got a username yet. So we've got some credentials here, so let's put them in a new file. So password in there. And now if we connect back to SMB, because there's nothing else we can try and log into, so the only thing we can kind of do is just use those credentials to log back into SMB. So let's close this down. And because Windows, let's exit out of this. Because Windows, wait, how do we quit? There we go. Because Windows is a bit weird with network connections, if we do net use now, you'll see it's actually remembered the connections to that share. The problem is that's going to be just using our anonymous access, and you can't connect to the same share on the same machine with different credentials. So what we need to do is just delete these. So we'll just do, I think it's start first. We'll just delete all connections. And then now we can do net use, put the share name in. Again, I can't type. So data, and this time we can put a username in. So we'll put Tempuser and the password, which was welcome 2019. So that completes successfully. So now when we go back to that share, Now we're connecting as that Tempuser account. So does that get us access to anything more? We can get into there, but there's nothing in there. I don't know why I left that there. I think I just wanted to make it look like there was at least something in the folder. It wasn't just an empty pointless folder. But yeah, we can't get into any of the other folders in there. But we do now have access to these folders that we didn't have access to before. So production reports, IT. Again, I put some fluff in here just to at least make it a little bit realistic, and just so that it wasn't literally just you run straight into the one file that you're supposed to find, because I thought that would be way too easy. But long story short, look through these folders, we eventually find this one, which is Notepad++, which is of course a legitimate program. These are legitimate XML files from it. In fact, let's open that with Notepad++. Right, so we are looking at the Notepad++ config file in Notepad++. And long story short, again, I know I'm kind of just skipping through things a little bit, but there's no point boring you with just looking through empty files and stuff like that. So yeah, eventually people should find this history section, which lists all of the files that you've previously opened. And in there you can see we've got HTB nest, which hopefully is pretty obvious to people, and that's the machine they're attacking. And we've got this secure $share, which we didn't know about before, although you could have figured that out. You could have found that share already with like SMB map or SMB client or something like that. But it tells us the extra folders that are under here. However, if we try and go to this, we go to secure $. In fact, yeah, let's just go to the secure $share. We can get in there and you think, cool, we can carry on. But we can't. We don't have access to the IT directory. Now, this was a little trick because people will assume that, oh, well, if I can't get into there, well, then I can't get to any of these files, you know, the subfolders. But the way Windows permissions work by default is that you only have to be granted permission to the folder you're actually trying to access. So like if we don't have permission to IT or secure $, that doesn't matter. As long as we have permission to access this CARL directory, we can access it. So because we have this path here, because we actually know about one of these subfolders that exists, I guess you could brute force it, but yeah, because we know that there is a folder in here called CARL, we can get straight in there. Again, because the permissions on this folder are set so that we have access, but on IT, they're not set. And again, you can change that behavior. It's called like bypass traverse checking. I think it's got a bit of a weird name, but yeah, there is an option you can change that will mean that it does check every step along the path, but by default, it won't. So we can get into here. We can look around again, just some fluff here just to kind of make it look semi-realistic. And eventually we will find this VB project. Now, I didn't want to just assume that everybody has Visual Studio or whatever, so I've made it a very simple project with just like 2 files in that you can just open in Notepad or whatever. So let's just open with Notepad++. And we can see here that this is just loading from a file called HqkLdap.exe, and then it's decrypting a password. So let's go and find that HqkLdap.exe. Now, I was kind of hoping that people would have found that already, because obviously when you're going through all this stuff, you're just looking for something useful. And there's this thing called RUScanner here, which has HqkLdap.exe in it. But just in case people didn't already find that, I named this, you know, RUScanner, this VB project, everything is all called RUScanner. And again, the config file, or that code that we were just looking at here, that actually specifically mentions ru_config.xml. So if you just search the SMB share for that, you would find it. So again, I've tried to make a couple of different ways that people could eventually find this file. But if we look in there, we'll see that we've got a username here, and we've got a password, which looks like base64, but if we just try and decode it with base64, you just get gibberish, so it's obviously encrypted. So let's copy that, and we'll say c.smith is our next username, and this is an encrypted password. And so we obviously need a way to decrypt that, and that's where this VB project comes in. We can see here it's decrypting a string that it got from the config, which is here, so config's there, and then the password in the config. So if we actually look at the rest of the VB project, if we go back to where we were, to make it easier, I'm going to actually open the full VB project. Yeah, we always want to open it in Visual Studio 2019, thank you. But yeah, you don't have to do this, you can just open each file in Notepad, but it just makes it a little bit quicker and easier if you do this. So we've got this where it's loading the config file, which we already know about, and then what it's doing with that is getting the username and the password from that config file, and we see here decrypting it. So if we look at this decrypt string method, just right click and go to definition, or you can press F12, and then essentially in here it's just checking for an empty string and then decrypting it, and we see it's passing in a load of parameters here. So let's have a look at that decrypt function, and here we've got those parameters, which is ciphertext, the key, the salts, and a lot of other stuff. So it's doing quite a lot of, like, not super straightforward crypto. It is just AES CBC encryption. There's nothing too wild about it, but it does a few slightly different things that in future I wouldn't do, like this whole RFC derived bytes thing confused quite a few people, like when they were trying to just recreate this in Python or whatever. So yeah, in future machines I would just do a more basic AES encryption routine, but this was taken from a program I'd written in the past and just something that I'd used, so I just kind of copied and pasted it. But luckily, we don't need to really understand any of this. All we need is to just pass our string in to this same function, because we've already got the encrypted string. So if we go back to module 1 here, the kind of intention was that people would just copy that whole decryption function into their own Visual Studio project or their own online compiler, because if you go online, search for like .NET compiler online or something like that, you find .NET Fiddle. This is probably the most common one, and you can just paste code into here, change it to VB, because that's what we're using in this project. So let's do that. Let's copy this whole utils class, which is where the decryption function is. So let's copy this whole utils class, just Control A and then Control C that in there, Control V, sorry. We do need to move these import statements up to the top with the other import statement, and then we should be pretty much good. So now we could do console write line utils and then decrypt string, because we've just pasted all this code into here. So now we can put our string in that we're trying to decrypt, which we know was this. That came from the XML config file. So I'll put that in there, and that should be pretty much good to go. We can just do console write line, and instead of writing out hello world, it should now write out the decrypted version of that string. So let's give that a go. We run, and we get this, which is the password. Again, in hindsight, I would probably made that a little bit more of an obvious password, because some people might just see that and think it's a load of gibberish and a load of junk, and they haven't done it correctly. So yeah, that's not the best, but I will say, and I should have pointed this out at the start, that I actually made this box when I was brand new to Hack the Box. I'd only completed one machine, and it was quite a sort of enumeration and like not very exploit heavy box. So that's kind of why this one is very enumeration based, and there's not really any actual exploits or any real hacking going on. It's more just enumeration, reverse engineering, figuring out, you know, a few different permissions and finding clues and things like that, which some people did criticize it for, and I think that's perfectly fair criticism. A lot of people said it should have been rated harder than easy, because it was just set as easy, not medium or hard. And the reason I rated it easy was because of that reason, though, because it doesn't have any actual hacking and like exploits involved. So yeah, anyway, getting back to this, we've got the password for this c.smith account. So let's do the same thing of deleting the connections and then connecting back as that account. Close all these. We'll have to close down this Visual Studio thing, because you can't delete the connections while something's accessing it. A little bit awkward, I know. So we'll just close all this as well. And now we'll do the same thing again. Data, and we'll do user of c.smith and the password of that. And I've put the wrong IP address in, so that's why that's taking a while. There we go, completed successfully. So now if we go back to this machine, one thing to point out as well is when you set the credentials for one share on a machine, it will use those same credentials for all the shares on the machine. So now, even though we only set it for that data, we can also get into users with the c.smith credentials. So if we go into c.smith's folder, because now we're connecting as them, we can see we now get the user flag. Finally, we finally get a user flag. So there we go, that's how to get the user flag. And from here, I obviously wanted people to kind of pick up on the next thing, so I stuck that in the same location that they've had to go to get the user flag, which is this. And this is where things get even more awkward, and again, I wouldn't do this now making a machine. This debug mode password here, if we go back to telnet into the machine on that 4386 port, so that was the only other port that was open, we get this HQK reporting service. And here we're seeing a folder called HQK reporting, so pretty obvious that these things are related. We've got a config backup file. Let's have a look at that. So this was only here to just prompt people to go and look at this port. And I'm really glad I did this, because what I've seen for a lot of people, like in IPSEC's video and a lot of other people's write-ups, when they first did an Nmap scan of this machine, for some reason it only showed port 445 open. I don't know if that's the way they'd done their Nmap scanner, if they only limited it to a certain amount of ports, I can't remember. But a lot of them only thought there was one port open. So I'm glad that I included this hint here to another port, because for some reason people didn't find it. Also, because a lot of people are using Linux, they don't use telnet, they use ncat or something. And that has a problem where if you type a command, press enter, it sends a different type of line feed or new line character basically. In Windows you have a CR and then an LF, so CR, LF like that. I can't remember, I think it's carriage return and then line feed. Whereas in Linux it tends to be just LF. So what this program is doing here, and this is a program I wrote, we'll take a look at the source code of it in a minute. And what this program is doing is it's looking for incoming text, incoming data that ends with CRLF, because that's how it knows when you've pressed the enter command, or the enter key, sorry. So if it only ends with LF, like it does on Linux when you send commands, it's just going to ignore that. So people would type in help, and it would just say unrecognized command. Or it would just, actually no, it wouldn't say anything because it didn't think they'd pressed enter yet, basically. A lot of people eventually realized to just use telnet, or to just, there's an option you can set with ncat that will make it send CRLF instead of just LF. But yeah, again, that's something I would do differently now because it tripped a lot of people up just over a stupid little thing. But either way, eventually people get the hang of it and they connect to this service and they realize that, yeah, they can look around the folders like we saw before, but there's this debug mode which says it needs a password. So if we type debug and we put something in, it says invalid password. So obviously we need to find the password for that. So luckily, where we found the user flag, we also found this file called debug mode password. But when we go into it, there's nothing in there. And if you look at the size, it says 0 kilobytes. And this is definitely the thing that tripped up the most people. When I was making the machine, I thought up until now it's been way too easy. Like, you literally just have to do some very basic SMB enumeration. And I thought people are going to just think this is literally pointless, it's too easy. Ironically, a lot of people actually got stuck before this point, so it wouldn't have been too easy really for an easy machine. So yeah, I kind of stuck this in to intentionally be kind of awkward, just to at least be a little bit of a challenge, or at least teach people something new. And it did teach people something new, but again, because people are doing it from Linux, it made it very awkward. Although actually, after seeing how people did do it from Linux, like the people that did figure it out, it's not really any more difficult than doing it from Windows. But for some reason, everyone thought you had to do it from Windows. But I don't know. Essentially, what we're going to do is, if we just open command prompt here, or PowerShell, because new shiny stuff. Well, that's funky, isn't it? I don't think I've ever opened a PowerShell window on a network share before. That looks really ugly. Anyway, if we do dir command in here and we do /a, I think it is. No, we can't do dir/a because it's PowerShell. Yeah, okay, we're going to do the old-fashioned way. Bear with me 1 second. Let's just do netuse. We'll just set like a random network drive to be, oops, that data share. Oh, it's users, sorry, wasn't it? Now if we go into R, and we do c.smith, I think it was, yep. c.smith, HQK reporting, and then where we debug mode password. If you do dir/a in here, and it turns out it's not /a, what is it? Is it /m? No, it's not. What is the command? Let's do /? and find the commands. Oh, there we go, /r. Display alternate data streams of the file. So if we do dir/r, now what we see is that even though we've got debug mode password text file in there with 0 bytes, there's also this extra entry with :password, and that's 15 bytes. So if we read that, and there's a weird way to read it, which is like the more command like this or something, debug mode password, text, password, I have to remember the syntax. Oh, that was correct. Yeah, so that's a weird ass way of reading it, but if you just Google online like how to read alternate data streams, that is one way you can do it. You can do it in PowerShell as well. It's just a little bit more verbose, a little bit more long-winded, so I prefer to do it this way. But essentially what's going on here is in the NTFS file system, you can have alternate data streams. So there's a default data stream essentially, which is what you see in here, is everything that you see when you double click on a file, when you inspect a file, just with its file name. So just with that, you always get the default data stream. But you can add alternate data streams, extra data streams. In this case, it's called password. And there are plenty of like GUI utilities and stuff as well that will manage all this for you and do all this sort of stuff for you. The only time I've ever actually seen this feature used legitimately is in Windows, if you download a file from the internet, it will add an alternate data stream to it called something like internet zones or something that basically just tells the operating system not to trust this file until you manually trust it. So let's go and have a look. If we look in my downloads folder, maybe there'll be some. Let's open command prompt here. Oh, we can't open command prompt because PowerShell has taken over that thing. So if we go into downloads, let's try it in there, see if we get any. Yeah, so you see here we've got Mimikatz trunk.zip, and then we've got this zone identifier alternate data stream. And basically that just tells it that this is an untrusted file from the internet. And if you go in, let's find that Mimikatz trunk. If you right click on it, go to properties, you'll see it says here, this file came from another computer. If we unblock that and click apply, then now that'll get rid of that alternate data stream. Do that again. Now we've just got Mimikatz trunk. There's no alternate data stream. So that's the only legitimate use I've seen for this feature. Nobody ever normally uses it like to store hidden things in or whatever. Like you could do, but it's pretty risky because if you ever move this to a non-NTFS drive, you'll just lose the extra data. Like it'll just copy the default data stream and the alternate data stream will just be lost. Which is what was happening to a lot of people when they attacked this machine from Linux. They would copy this like whole file share down to their own machine and that alternate data would just get lost. So they would just be looking at this blank file going, well, there's nothing here. So yeah, there is a way to do it with SMB client. I've seen in people's videos and write-ups, you can just do, I think if you type all info, that will show you the alternate data stream. And then if you type just get or something and include the alternate data stream name, you can get it that way. So with that rather long-winded explanation out of the way, this is the debug mode password. So let's stick that in there. Debug is that. So now if we go back to our telnet session, the connection's been lost because the session timed out. So let's just connect back. And now we can do debug and enter that password. Now it says debug mode enabled. Use the help command to view additional commands. So now we've got some extra commands here. Some of them don't really do anything, like service. I included this one just to kind of give people a little bit of information about where the files were located and stuff like that and what account it was running as. It's not particularly useful. There's also this session one, again, doesn't really help in any meaningful way, but I wanted to make it a little bit more interesting. The main one though that's more useful to us now that we didn't have before is this show query option. So let's take a step back and explain what this service is supposed to be. It's supposed to be, like if we just do help, this service allows users to run queries against databases using the legacy HQK format. That's not a real thing. I intentionally picked a name that if you Google that, you don't really find anything. I didn't want people to get kind of lost down a rabbit hole looking at some other database format or whatever. HQK is not a thing. I wanted this service to be like a really old school thing that you do find in enterprise environments. You do find old nasty stuff like this where people have to log in with Telnet and download files and stuff. Honestly, I've seen it in like modern environments. It's crazy that stuff like this is still a thing, but it is. So the idea was that a user would go in here and it, again, in a very old school way, you would type list and it would give you a list of the queries that you could run to, you know, find out things about products sold or whatever. So if we wanted to run the query, if I could type, we would type run query and then the number of the query. So in this case, we want to run the first one, we type run query 1. And then in this case, it just says invalid database configuration found because I didn't actually bother implementing a whole database and returning products and stuff like that. In hindsight, I wish I'd changed that error message a bit because I think some people got lost and just started trying to troubleshoot this database configuration. Again, it's not ideal, but what I wanted to do was just have a service that could be exploited by using its built-in commands to actually run and show queries, because the queries are actually just files. So if we do show query and then we do 1 again, we see it just shows some kind of format of a file that actually contains the definition of this query. But the setdir command can be used to go into different directories. So let's do setdir comparisons. And then we do list again. We see there's different queries in here. But if we do setdir ... to go back up a level, so now we're back where we started, what we can do is do setdir ... again, which obviously you're not supposed to do because this was just where we started. So you would think the program wouldn't let you keep going, but it does. And if we do list again, now we can see we're actually seeing just real folders and files on the hard disk. So it turns out these queries were just files and these folders were just folders, but the program's just kind of interpreting them in a special way because they're these special format query files. But once we break out of that, we can actually just see normal files. And now because we're in debug mode, we've got that show query option, can't remember where it's gone, but we can do show query and type the number of the query that we want to show. In this case, we're actually showing files, not queries. So we'll do show query 3, and we get the contents of this XML file. Now, this particular XML file doesn't help us at all because it just tells us the debug password, which we've already got. It tells us the folder we're in and the port we're running on. But if we look around a bit, so if we go set dir logs, we'll have a look in there. The logs, so we can do show query 1 to read that. And then we get file over size limit. Are you sure this is a HQK query file? The reason this file size limit is here is because I didn't want people to be able to just download like huge files or like download the entire hard drive or whatever using this feature. One, because there's no need, so I'm trying to sort of limit people to the actual thing they're supposed to be looking at, because they're only supposed to just read text files and XML files with it, really. And two, because I didn't want it to kind of bog down the server if people are using this to read massive files, like it would just slow everything down. So yeah, it's kind of just a little backup there from my point of view, just a little safety net. But anyway, if we go set dir ... get back to where we were. If we look in this LDAP folder, list, we see this ldap.conf file, so let's try show the contents of that. Right, so now we're getting somewhere because we're getting this, domain set up. Again, another thing I would do differently in hindsight is not mention domains, because a lot of people saw this and thought, oh, LDAP's running on this machine and this is the domain it's in, and they started trying to attack that. None of that exists, like this is not a real thing. That was just me trying to make it look realistic. I don't want to just literally just put a text file that just has a password in it. Like why would that be there? I'm trying to make it look realistic at least. So yeah, this was supposed to be realistic because it's, this is the kind of stuff you would actually have in a config file for a program that has to integrate with LDAP. You'd have the domain name, the port, the OU that it's looking at, and the username and password it's using. So we can see the username as administrator, so we know this is the one we want to be after, and this is the password. But again, it's almost certainly encrypted because of the look of it. So let's copy that, and we'll just stick that administrator. And so yeah, we need to find a way to decrypt that. Again, if you just try and base64 decode it, you'll just get nonsense. What we can also see, if we look in here, is we've got this HqkLdap executable. Now we can't do show query on that because it's too big, but if we go back into where we found the user flag and where we sort of started this whole adventure into the HQK stuff, there's this AD integration module, and we've got a copy of that executable there. So you see this one here. Now some people got a bit stuck here because they knew they wanted to download this executable because that's quite obviously what's going to be decrypting this password that's in this file, but they couldn't figure out how to download it because they'd forgotten that they actually had a copy of it over here, or they never got around to looking in that folder or whatever. And yeah, that wasn't a great design. So we know that this executable decrypts the password we got in this file, this one over here. So what we can do is right click on this, open with dnspy, and obviously there's other .NET decompilers and stuff, but dnspy seems to be the most common one. It's pretty good. And what this gives us, if we expand it and look inside it, this gives us basically the source code for the entire program. Except we've gone to the wrong thing. There we go. Basically gives us the source code for the whole program. So if we go to the main module, this is like the entry point. So we've got submain here, standard stuff. And you can see it's checking for like certain command line arguments. It's checking to see if a file exists, which is one of the command line arguments. It's checking to see if another file exists. Again, yet another thing in hindsight I wish I'd done differently. A lot of people thought like they should find this file. Again, though, that was just me trying to make it look realistic. Like, it's supposed to be something that imports data into LDAP or whatever, so it's not particularly convincing, but this was my attempt to make it look sort of realistic. So, like, it does actually start... Does it actually start doing a thing? Yeah, it does actually start doing a real Active Directory search and everything. So, it did put some effort into making it realistic. That would actually search an AD domain if all this was set up correctly. But the important thing, if we go back to where we started... in the main method. The important thing is we can see here it's reading all lines from whatever was passed in as the first command line argument, and it's looping through them, and it's saying the password, if the line starts with password, then do this cr.ds and pass in the rest of the contents of that line basically. So if we look at that cr.ds function, it's basically exactly the same as what we had before, where we've got a function that just decrypts and encrypts strings. It does all the same stuff, RFC 29, blah, 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 derived bytes, AES encryption. all the same stuff that we did before. And this was kind of intentional in that the people who've got this far have already had to deal with this same thing, but they've just had to take an extra step this time in actually decompiling the executable and finding this function for themselves. Whereas before, it was just handed to them in the source code files that they got on the SMB share. So yeah, I wanted to kind of train people in the first step in, they have to figure this stuff out and be able to copy and paste this and pass in the string they want to decrypt. And then in this sort of second stage, in the root stage, they have to actually decompile the executable to get the source code. Hopefully that makes sense. But long story short, we can just copy and paste this whole thing again. And this is actually where people did some different stuff to what I was expecting. And I actually prefer other people's way of doing it to the intended path. But if we just ditch all this again, and we'll paste in that class that we got. What are we complaining about here? That doesn't exist now. And what are we complaining about down here? Memory stream doesn't exist. So we need to import something else. What are we importing up here? System.io. Okay, so import system.io. There we go, so now that's happy. Right, so now we've got this whole class that'll do all the encryption and decryption for us again. So we can just do crds, because that's what we saw the program doing. If we go back to main here, crds, and it just passes in the password. So that's all we need to do again. So we take this, and again, I'll explain in a second what people did differently to this. But if we go back here, just to prove that the intended path works, we take that, and we run that. We get this password down here. So that is the administrator password, and obviously then it's very trivial to, there's two ways to do this as well. You can either take that password and just connect back to SMB through the C$ share, or you could use ps.exec to remotely connect and start a service and then get a shell and do it that way, which is actually what most people did, but I kind of intended for people to just connect to the C$ share in the same way that we've done all the rest of it. And then obviously you just get the root flag from the admin desktop. So let's talk about what people did differently. In this part here, quite a few people actually just modified this code so that they didn't have to like compile it all themselves or anything and like run it in here and pass things in. They just modified this code here, so they took out all these checks that are checking for certain command line arguments or whatever, and then you can actually get dnspy to just compile it for you. I think you do save module, I can't remember. It's been a while since I actually used this to actually do like edits and compile, but it's pretty straightforward. You basically can just delete the code. In fact, let's figure out how to do it. How do we do it? Let's go edit method. So decompile it to whatever we want. You can also change this to be C# instead. Like I know a lot of people don't like VB. You can change this to be whatever .NET language you want. But yeah, they basically just took out all this code here. Let's take that out, and then we should have an endif down there. Took all that out, and just let the program just run straight away and just find the config file. So they take that out and just put in the path to their config file, wherever they put it, ldap.conf, whatever. They do that, and then they just compile it. And again, I can't remember where you do that. Right-click, compile. Cool, so that will just create the executable, and then you can just run it. Make sure you've got your ldap.conf file, make sure that password's in there, and then they would just run that and just have it output the password. So you could do something down here. You could just do like console write line, and just do ldap search settings .password, and that, because we know that's where the password is stored after it's run the decryption function. So yeah, they just did something like that, and it would just output the password, and then compile it, run that, job done. So that was quite interesting. Like I didn't expect people to actually modify the program and recompile it and stuff like that. That was cool. And I guess that brings us on to the main problem that we had with this machine when it first launched, which was the unintended path to root. Now, what happened here was people would get to the first stage where you would just be browsing this as an anonymous user. You would get into here. I can't remember where it was. In here, yeah. They would get these credentials here. And they would use those for some reason. I don't know why anyone would try this, but for some reason people tried it. They would take these credentials and try and use them with ps.exec. Now, if you don't know what ps.exec is, it's a tool that will connect to a remote machine. It will try and create a executable in any writable share. Okay, so at the moment, none of these shares are writable. Like we can't create files in here. Let's prove that to you. We don't have permission to create any files in here. However, when the machine first launched, the user's share, for some reason, you could create stuff in. So you could create a new folder in here. That's since been fixed, but that on its own wouldn't be a problem. Like, so if they use ps.exec with these credentials, it connects back, it writes an executable to whatever folder you want, fine. But then its next step is to create a service, a Windows service. If we go into services.msc, you'll see what I'm talking about. So create a service that will run that executable that it's just written to the share, and it will run it as local system. And then there you go, you've got straight away got local system, which is basically root on Windows. So you've got local system permission, you can see all these things run as local system, and you can then just own the whole machine, like you've got access to everything. So what stops people doing that normally from anything other than an administrator account is the fact that no one can normally create services, only admins can create services. Which is why I have no idea why people would try it with the first set of temp user credentials you get, but people did. And basically, the reason this was a problem is if we use SC, we do SD show SC manager. Oops. So this will show you the security descriptor for the service control manager. So the service control manager is the thing that manages all of these services. Who knew? So yeah, that has its own permissions as well. So each of these services have permissions. Like if you wanted to do, if you want to see the permissions for the Windows Update service, that's what its name is. So these are the permissions, and I know this looks absolutely horrible. Let me show you it in a nicer view. Let's use this tool here. This is a program that I downloaded, free tool. So we'll just say we want to get permissions from local computer. There's no built-in nice way in Windows to view these permissions. This is all you get. This is all you get in Windows to view these permissions. You can do it in PowerShell and it's equally ugly. But if we look here, so let's go to the Windows Update service. Wherever it's gone. Oh, I renamed it to Windows Update 2 when I was testing something. So these are those same permissions that we're seeing in command prompt. Let's get rid of telnet. So these permissions here for the Windows Update service, those are the same permissions that we are seeing in here. So we've got authenticated users, have got these permissions, they can start the service, but they can't stop it, they can do these other things. Administrators obviously can do everything, system can do everything. So that's what you're seeing here. So the AU there is authenticated users, so that is this entry. So this whole section here, oops, this section here is basically this first section that we're seeing here. So it's saying authenticated users is the user account, A means allow rather than deny, which is why we're getting allow rather than deny here. And then these terrible strings here represent each of the permissions. But it's not anywhere near as straightforward as you would think. Like some of the letters stand for things that relate to registry keys, even though these are being applied to services. It's very messy. Like this whole system called SDDL, or Security Description Language or something, I think it stands for. This whole thing, I despise it, but it's how Microsoft display permissions in a lot of places. And yeah, coming back to the problem and the reason why people can't normally create permissions, or sorry, create services. If we go and look at the service control manager in this tool, we can see that authenticated users only have permission to connect, which means they can view, well, it doesn't even mean they can view services because there's a separate permission for that. But it just means they can connect to the service control manager. So then any interactive users, so someone who's actually logged on interactively, not in like a remote shell or anything like that, just logged on at the computer, they have permission to list services, which is why we can list services here. And then like system and administrator have full control or close to full control. So administrators have full control there. So like I said, ordinarily when people got these temp user credentials, they would be able to write to the share because at first that share was writable. But then when it came to start a service, that should have failed because by default, they're just going to be in this authenticated users group. They're not admins or anything. They're not even interactive. So they shouldn't be able to create services because they don't have this permission here, create new services. However, when I was testing something, I can't remember what exactly, but when I was testing something on this VM before I submitted it to Hack the Box, for some reason I changed these permissions so that authenticated users did have permission to create new services. And funnily enough, this actually happened on another machine recently, the Resolute machine that was recently retired from Hack the Box. They'd basically done the same mistake as me. They'd granted all users full control to the service control manager. Now, the reason very few people picked up on that being an issue there was because they didn't have a writable share. So when people did just throw ps.exec at the machine, even though it shouldn't work, it would just fail because it didn't have permission to actually create the service executable in a share anywhere remotely. But if you actually got a remote PowerShell session going and just created that executable yourself manually, just copied it manually, you could just straight away create a service that runs as local system and runs that executable and just get root straight away and bypass most of the machine. So yeah, it's not just me that made that mistake, but certainly something I will double check on every machine before I publish it again in future. If you wanted to change that, by the way, if you wanted to check that, sorry, in here, you do sc manager as a service name, and that will give you these same permissions here. So you see here, we've got authenticated users has only got this CC permission, which in this case means connect. But administrators, which is BA for built-in administrators, they've got KA, which means full control. There. So if we wanted to change this, we could copy this whole thing. Let's copy that, and we'll do SD set instead of SD show, and then we'll put that back in, but we'll change authenticated users. So this section here, we'll change that to KA, like built-in administrators. Not access denied because we're not running the command prompt as admin. My bad. Let's do that again. So just to clarify, this is purely just to kind of mirror the way I had it set up to start with when the machine was first submitted to HqkLdap.exe. Right, so now we've done that. If we refresh this, we should see, go on Service Control Manager. Now authenticated users have got full control, just like administrators have. And this was basically the state that the machine was in when I sent it to HqkLdap.exe, and the state that that Resolute machine was in as well. And that's what allowed people to use psexec on this machine to just instantly get root. So yeah, let that be a lesson to you. Always check these things. And let's change that back before I forget as well, so that it doesn't mess me up in future for something. It was CC in there, wasn't it? Let's just double check that. Yeah, so now we're back to how it should be. So yeah, always double check things before you submit a machine like this, obviously. And I don't really blame the HqkLdap.exe staff for not picking up on that, because it is a pretty weird thing. Like, you've got to really go out of your way, as you've just seen, to actually set this, and you would never normally have a reason to do that. I don't really understand why the guy who made the Resolute machine did that. I think just to make it easier for us to find the DNS service, because as you've seen, normally we can't even list services as authenticated users. So maybe they just wanted to allow us to list services, but instead of figuring out this nonsense, which specific letter combination means list services, they just did full control. So that's it for this one. I will be doing another video in future that actually goes through me making a machine, like from scratch. Oh, I did also say I was going to show you the source code for that program as well, didn't I? Right, 1 second. Okay, so this is the program that I wrote that runs that service that runs on port 4386. It's pretty scruffy, it's pretty, it's not great, but essentially it's just a Windows service. So we've got this Windows service here, and this is what gets run when you start the Windows service. So it goes through, loads some stuff from the config file, and then it runs this session manager start. So we go to that, I'll just make that a bit bigger for you. Starts a new background thread, runs this method here, opens a new TCP listener on the port that we specified, and then just loops through waiting for connections. Now, I was quite worried when I made this that when everyone attacked it on HqkLdap.exe, it would get, overloaded, or there'd be some kind of bug that meant it didn't close people's connections properly and it would just leak memory and all this stuff. Because obviously I can only test it with myself. Like, I can just run the server-side program and I can connect to it with Telnet and see if it works. And it worked fine. But I was quite worried that it wouldn't work that well when hundreds of people were attacking the machine. But there were no problems reported with that, so I'm pretty happy with that. Let's get to the interesting stuff, because there's a bit of multi-threading rubbish and stuff in there to deal with. But somewhere, let me try and find where it is. We've got client connected there. So we do a new network session there. So I think that's probably the interesting class. It is. So this is the class that actually kind of handles somebody sending data to it. So you can see here, when someone first connects, it'll just send that banner, which writes to the client by using just the network stream. Well, it's a stream writer that writes to the network stream, just general .NET networking stuff. And then it will load the query files, so it knows which files it's currently got, so that when you run list, it can show that. So this will be where it actually does all that and handles each command somewhere. Yeah, so this will be where we're looking for. Yeah, so this is the thing that kind of stopped it working on Linux very well. Is we had, if the data string that's received ends with VB new line, which is CRLF, as you can see there. So that's where I was talking about the Windows default, CRLF. Or if it just ends with a carriage return. Now, to make it work on Linux, that should have been just VBLF. That would have probably fixed the problem. But I had it the wrong way around, and it was only checking for a carriage return or a carriage return followed by a new line feed. So yeah, if it does end with that, then it'll actually process the command, which is where we've got basically the whole logic of the program to actually run each command. Again, nothing fancy or anything. Like if it's quit, it'll just write, was it something I said? It'll close. If it was help, it'll write the help text. There is actually a little Easter egg in here, actually. If you type HTB, you get, it's supposed to be like a smiley face, I think. Obviously, it doesn't look like it there. Let's try it. Let's see what it looks like. HTB. It's not the best, is it? It's not going to win any prizes for like the best ASCII art you've ever seen. I mean, you can kind of, yeah, 2 eyes, a nose, and a mouth, sort of. It's not great, okay? I was never much of an artist. So yeah, other than that, that's the only interesting thing in here, really. The rest of them are just, yeah, just normal stuff. Yeah, it was kind of awkward to write all this because, again, I didn't really know how well it was going to work, if people were going to find some, like, weird exploit that I hadn't thought of. That's the main thing I was worried about, was that people would just break this service entirely and just, you know, be able to read every file in the file system and just do whatever they wanted. But no, it seemed to work pretty well. Also, this whole, like, checking the password and stuff, I was worried that wasn't going to work particularly well. But again, it all seemed to work pretty well. There weren't any unintended paths with this. It was just the service permissions that we've just been through. So yeah, as you can see, there's quite a lot of work to actually get this working. Like, in hindsight, probably shouldn't have put that much work into a fake service, but whatever. It was good. Most people seem to enjoy the machine. Everyone's kind of main criticism, I think, was just that it shouldn't have been rated as an easy machine. It should have been rated as a medium machine. Somebody even said hard, but I don't think it should have been rated hard. I think medium's fair enough, but again, my reason for doing it as an easy machine was that there isn't really any actual hacking involved. There's no exploits. There's nothing that complicated. It's just SMB enumeration and reverse engineering a .NET program, which is like the easiest thing ever to reverse engineer. In terms of, you know, you don't need to know any assembly code or anything. You just literally right click, open in dnspy, and then you just get the source code. So yeah, I've also got another machine that's currently live on Hack the Box called Cascade, which will be retired sometime soon, I guess, in the next few weeks probably. So I'll do a video going through that. And then I'll also do another video going through the current boxes that I'm working on, like actually making them from scratch. Because obviously this time you only kind of saw the end result. But I think it'd be good to go through like my kind of choices and decisions and stuff as I'm doing it. So there will be plenty more videos in a similar kind of style to this where we're going through machines that I've made. But yeah, that will do for this one.